Hello, my name is Geoffrey West. I'm a professor at the Santa Fe Institute in New Mexico, and I'm here today at UCLA to talk on cities, but in particular on their relationship to sustainability. So what I'm going to be talking about is inspired by ideas in biology on the one hand, and on the other hand, the extraordinary impact that human beings have had in the last 200 years. I think one of the most interesting things about our natural evolution is that our metabolic rate, that means how much energy we need per day to stay alive, that's your 2,000 food calories, it's not often appreciated that that corresponds to just a light bulb of about 90 watts. That's all we need to stay alive. We are extraordinarily efficient. So natural selection has evolved this extraordinarily efficient machine that we are. And if you add in all of our activity for a day, as a natural human being, it's about 250 watts. And in fact, there are still hunter-gatherers on the planet that use only about 300 watts to stay alive, including all of their hunting and gathering and activities. So you can ask the question, how much does a typical American use per day to hunt and gather, meaning have all the appurtenances and all of the facilitating aspects of their life to have the kind of quality and standard of living we have, meaning the cars and the electrical lights and the roads and all the rest of it? Well, that corresponds to this extraordinary number of about 11,000 watts, namely 100 times more than just the amount of energy that you have just sitting around. And you can turn this around and ask the question, how big an animal would be using 11,000 watts? And it turns out that corresponds to an animal of about 30,000 kilograms, which corresponds to about a dozen elephants. So each one of us in the United States is actually operating as if we are consuming energy at the rate that a dozen elephants need to support themselves. In the last 200 years, beginning with the Industrial Revolution, this has been the greatest impact of human beings since we have evolved from hunter-gatherer communities into becoming cities and towns across the planet. And this impact has been felt with the growth of many cities across the planet. So given that, it becomes a sense of urgency to start to develop a serious science of cities. The idea that we need to develop something that is based on underlying principles, that is quantitative, potentially mathematizable, and hopefully predictable. So the question is Los Angeles a scaled-down New York and a scaled-up Santa Fe, for example? And if that is the case, that would imply that there are underlying, potentially transcendent universal laws that are governing the development and growth and evolution of those cities. So as an example of these remarkable scaling laws that exist, first of all, in biology, is that think of metabolic rate, which is the amount of energy you need per second or per day to stay alive. That's the 2,000 food calories. You can ask, how does that change as I change the size of the animal, say from a mouse to an elephant? And what one finds is something kind of remarkable. There is a systematic behavior that is manifested in biology, so that one can predict fairly accurately, really, on the average, what the metabolic rate is for any animal. And it follows a very simple law, and that simple law has built into it something that is also extraordinary about biology, and that is the bigger you are, the less energy you need per second to stay alive. So there's what we call an economy of scale. Furthermore, as you get bigger, this economy of scale and this kind of scaling law also implies through the network dynamics that sustain life that the pace of life decreases with size. So animals live longer the bigger they are, their hearts beat slower, and so on. Now, when you come to socioeconomic systems like cities, amazingly, one finds similar kinds of behavior, that indeed, just as the elephant is a scaled-up giraffe, which is a scaled-up human being, which is a scaled-up mouse, despite the externalities of it, that is, they look very different, one can ask, is Los Angeles a scaled-down New York or a scaled-up Santa Fe? And remarkably, when looking at the data, one finds that they are scaled versions of one another, despite the fact that they look physically quite different. So this work looks at metrics like the length of all the roads, or the number of gas stations, or the wages per capita, or the number of patents produced. But all of these scale systematically across the complete spectrum of cities, from New York all the way down to the smallest cities, so that in a certain sense, you say the size of the city, I can tell you how many police it will have, how many AIDS cases, how many patents it will produce, what is its GDP, and so on. All of these things on the average, so within, say, 85% accuracy. And this is kind of extraordinary, because it means that underlying all of the urban planning and all of the history and all of the geography and all of the cultural phenomena that take place in cities and all of the political decisions made, at the 85% level, there's another dynamic that is going on, transcending all of those particular kinds of inputs. And that dynamic is to do with the social networks of human interaction, because the one thing that transcends all cities, no matter where they are, that is common to all of them, is the fact that they are occupied by human beings, and it is the dynamics, and meaning also the clustering of human beings into families, jobs, and so on, that is being manifested in cities. And cities can be therefore thought of as facilitators of human interactions, and the best cities are ones that facilitate human interaction in a way that produces more ideas, more wealth, more innovation, and so forth.